Hello friends, welcome to see the continuous wave radar. The continuous wave radar basic use of the radar is that basically in the radar system the same antenna is used for both the transmission and the reception of signal. We can use this type of the radar when the target is stationary, means the target is not movable, or when the radar can operate with the pulse signal. Actually, when the target is not moving, or when the radar operates with the pulse signals, at that time we are using the same antenna for the transmissions and the reception of the signal. The radar which operate with continuous signal for detecting non-stationary target is called as the continuous wave radar, or it is simply known as the CW radar. This radar requires the two antenna. One antenna used for the transmitting signal and another antenna used for the receiving signal. Okay, so this is the continuous signal radar. We know that CW radar contains the two antenna. One is known as the transmitting antenna, another is known as the receiving antenna. And the block diagram of continuous wave radar is like this. This is the continuous wave radar system for detecting the moving target. For the stationary object or stationary target, we are using the pulse radar system. Okay, and this is not pulse radar or the pulse wave transmitter. This is the continuous wave transmitter which is used in such types of the radar for detecting the moving target. Okay, here the continuous wave transmitter. This is the continuous wave transmitter. Okay, and this continuous wave transmitter produce the continuous wave. Means the sine wave is produced by this CW transmitter, and this CW transmitter is connected to the mixer. Similarly, this is connected to the transmitting antenna. Okay, and this is the local oscillator, and as usual the function of local oscillator is to produce the frequency. Okay, and the frequency produced by this local oscillator is Fi, and that frequency is provided to the mixer 1, and this mixer 1, as the name of this block is mixer, therefore this mixer mix the two frequencies, one coming from the CW transmitter, another coming from the local oscillator. And here the local oscillator produces the frequency FO, and this CW transmitter produces the FI, frequency FI. And these two frequencies are mixed by this mixer, and at the output it produces the sum and difference of the two frequencies, that is the Fi plus FO and FO minus Fi. Both frequencies are at the output of this mixer. Okay, then this is the sideband filter, and the function of the sideband filter is to choose either the upper sideband frequency or the lower sideband frequency. Sideband frequency means what? The sideband frequency means the sum of the two frequencies or the difference of the two frequencies is known as the sideband frequency. FO plus Fi is known as the upper sideband frequency, and F4 minus Fi is known as the lower sideband frequency. And out of the two sideband frequency, only one sideband frequency is um, filtered by this sideband filter. Okay, suppose this sideband filter allow only one type of the frequency, that is the F4 plus Fi. Means the upper sideband frequency is only move through this filter. So that frequency is provided to the mixer 2. Okay, and this mixer having the two input, one input from sideband filter and another from the receiving antenna. Okay, and this mixer can produce both sum and difference of the two frequencies, that is the F4 plus Fi and F4 plus minus FD, which is applied to the mixer 2. So mixer 2 will produce the output of the two frequencies of 2F4 plus Fi plus minus FD, or Fi plus minus FD. Okay, and that frequency is known as the intermediate frequency, or the output of the mixer is the intermediate frequency, that is the IF frequency, and therefore this mixer 2 gives the intermediate frequency, and that intermediate frequency is amplified by this amplifier, and the name of this amplifier is the IF amplifier. So this intermediate frequency is amplified by this amplifier, and it is provided to the detector, and the function of detector is to detect only the frequency that is known as the Doppler frequency, FD, and therefore this detector allows only the Doppler frequency to the Doppler amplifier, and this Doppler amplifier amplify that Doppler frequency. Okay, then that is provided to the indicator, and indicator indicates the information related to the velocity and whether the target is unbound or outbound. Means the information about the target is indicated by this indicator. So the continuous wave radar gives the accurate measurement of relative velocity. Hence these are used mostly where the information of velocity is more important than accurate range. For the moving velocity of the target, for the detection of the moving velocity of the target, such types of the uh, radar is used. That is known as the continuous wave radar. So this is the continuous wave radar. Okay. Thank you. Thank you for watching this video.